You are 10 minutes late for work. You run outside, coffee in hand, only to find your driveway has turned into a literal skating rink. Your car is encased in a shell of transparent armor. You do what any of us would do. You grab that heavy, crinkly bag of rock salt and start tossing it like you are feeding imaginary chickens. Within minutes, the ice starts to hiss, crack, and turn into slush. It feels like magic. But have you ever stopped to ask, why? Salt is not hot. It is not a tiny heater. If you put a thermometer in a bag of salt, it is just as cold as the air around it. So how does a cold crystal destroy a solid block of ice? The answer is not what you think. It is not about friction, and it is not about burning the ice away. In fact, salt is actually performing a microscopic heist, stealing the one thing water needs to stay solid. Every winter, cities across the globe dump over 20 million tons of salt on the roads. That is enough to fill 2,000 Olympic-sized swimming pools every single year. We spend over $2 billion just on the salt itself, not to mention the billions in damage it causes to our cars and bridges. We are obsessed with this stuff. But to understand why, we have to look at a secret war happening on your sidewalk. A war between molecules that never stops. To get why salt melts ice, you first have to realize that ice is actually a lot busier than it looks. If you look at a piece of ice sitting on your porch, it looks perfectly still. But on a molecular level, it is a chaotic border zone. There is a constant, invisible battle happening right on the surface. Saltwater molecules are freezing, locking themselves into a solid crystal structure, while other molecules are breaking free and turning into liquid. In normal freezing weather, these two processes happen at the same rate. One molecule joins the crystal, one molecule leaves. This is called dynamic equilibrium. The ice stays ice because the joining team and the leaving team are perfectly matched. But then, you show up with the salt. When you sprinkle salt onto that ice, you aren't just adding flavor to the sidewalk. You are introducing a chemical saboteur. You see, salt, specifically sodium chloride, is a social butterfly. As soon as it touches the tiny microscopic layer of liquid water that sits on top of all ice, it dissolves. It splits into two separate ions, sodium and chloride. These ions are like uninvited guests at a very organized dance party. The water molecules want to hold hands and form their neat hexagonal patterns to stay frozen. These salt ions get right in the middle of them. They physically block the water molecules from hooking back onto the ice crystal. Think of it like this. Imagine a game of musical chairs. Usually there are exactly enough chairs for everyone. But the salt ions come in and sit on the chairs, but they refuse to play the game. It is also why, if you ever try the salt and ice challenge that was popular on the internet years ago, you end up with a literal chemical burn. The salt forces the ice to melt so rapidly that it drops to temperatures that can instantly destroy human skin cells. Please, do not try that at home. But salt has a weakness. It is not an invincible ice slayer. If you live in a place like Minnesota, Alaska, or Canada, you might have noticed that on the most brutally cold days, when the temperature hits -20 degrees, the salt trucks just stay home. Or if they do go out, the salt doesn't seem to do anything. The roads stay white and lethal. Why? Because salt needs a liquid bridge to start the process. Remember, salt can only do its job if it dissolves. If it is so cold that there isn't even a microscopic film of liquid water on the surface of the ice, the salt just sits there like a pile of useless rocks. For standard rock salt, the magic stops working effectively once you get below about 15 degrees Fahrenheit. At that point, the salt can't pull enough heat from the air to start the melting process. It is just a crystal sitting on top of another crystal, staring at each other. This is why you might see cities using different flavors of salt when the temperature drops. Have you ever seen a liquid purple or blue spray on the roads before a storm? That is often calcium chloride or magnesium chloride. These are the pro versions of road salt. While your table salt, sodium chloride, can only break down into 2 ions, calcium chloride breaks down into 3. More ions mean more chairs taken up in our musical chairs analogy.
Calcium chloride can keep melting ice all the way down to negative 25 degrees Fahrenheit. It is more powerful, but it is also much more expensive and can be even more corrosive to your car's undercarriage. And speaking of your car, let's talk about the dark side of this winter miracle. Salt is a double-edged sword. While it saves thousands of lives by preventing car accidents, it is also a slow-motion disaster for engineering. Salt makes water more conductive, which speeds up the process of oxidation, also known as rust. If you live in the salt belt, your 5-year-old car might look like it has been at the bottom of the ocean. The salt gets into the microscopic cracks in your frame, pulls in moisture, and starts eating the metal from the inside out. It is even worse for our environment. All that salt has to go somewhere. When the snow melts, 20 million tons of salt wash into our streams, lakes, and groundwater. We are essentially turning our freshwater ecosystems into saltwater ones. Some lakes in the northern United States are now so salty that the local fish and plants are struggling to survive. It is a massive environmental trade-off. Do we want safe roads today or clean water tomorrow? Scientists are frantically looking for alternatives. Some cities have tried using beet juice. Yes, actual juice from sugar beets. The sugars in the beet juice work similarly to salt, interfering with those water molecules trying to hold hands. Plus, beet juice is sticky, so it helps the salt stay on the road instead of bouncing into the grass. Other places have tried using leftover brine from pickle factories or even wastewater from cheese making. Imagine driving down a highway that smells like a giant mozzarella stick. It sounds funny, but it is a serious attempt to reduce the amount of pure salt we pump into the earth. So the next time you are standing on your driveway, throwing those white grains onto the ice, take a second to appreciate what is actually happening. You aren't just melting ice. You are interfering with a molecular dance. You are using chemistry to manipulate the very freezing point of nature. You are participating in a global struggle between public safety and environmental health. You are, in a very small way, a master of thermodynamics. You are no longer just a person with a bag of salt. You are a molecular disruptor. You understand the why behind the hiss and the how behind the slush. You know that salt doesn't bring the heat, it just breaks the rules. Before you go and wash that salt off your boots, I have a question for you. What is the weirdest thing you have ever seen someone use to melt ice or get traction in the winter? I have heard of people using kitty litter, sand, and even birdseed. Tell me your best, or worst, winter survival hack in the comments. If you found this deep dive into the science of your sidewalk interesting, make sure to hit that like button. Share this with someone who is currently complaining about the snow, and don't forget to subscribe so you never miss another chance to see the hidden world inside your daily life. Thanks for watching.